In this example, I'm going to solve this logarithmic equation. The reason it's a logarithmic equation is because my x is part of some logarithmic functions. When I'm solving a logarithmic equation, the first thing I have to think about, do I have the log on only one side of the equation or on both sides? And here it's only on one side of the equation. So the technique I use there is I try to rewrite it so that I just have a single logarithm equal to a number. And so I'm going to have to condense this from 2 logs down to 1 log. Fortunately, we have a property of logarithms that allows me to do that. I see the minus here, so this is the difference of 2 logs. And there's a property of logarithms that says instead of the difference of 2 logs, I can do the log of a quotient, which would be the log of a division problem. And so I can rewrite this with a single log, just log base 3, but I would have the first part, x plus 17, divided by the second, x minus 9 equals 3. And now I can rewrite this in exponential form. The thing to remember when going to exponential form is that the base stays the same. So this is log base 3, so I'm going to end up with 3 to a power. Also remember that the logarithm is equal to a missing exponent. So this 3 over here is my power. So I'm going to get 3 to the 3rd power equal to this fraction. And that's what I write next. And then of course we just say, well, what's 3 to the 3rd power? 3 times 3 times 3 is 27. So I'm trying to solve for x, and x is part of a fraction. Typically, solving equations, we want to clear the fractions, get rid of any fractions. That would be multiplying by the lowest common denominator, or LCD. In this case, I only have one denominator, so I'm just going to multiply both sides by that x minus 9. So I'll keep the 27, and then I'll multiply by x minus 9. And then I'll keep this fraction, but then I'll multiply by x minus 9. And of course, it's really x minus 9 over 1. I don't really need to write that, but that helps me realize these x minus 9s cancel out. That was sort of the point of that. I'm going to have to distribute over here. I'm going to have to multiply 27 times both of those parts. So I get 27x. We might have to use our calculator. 27 times 9 is 243. And then here I'm just left with x plus 17. In this equation, I just have x to the 1st power. So it's a linear equation. That means I can get just all the x's together. So I'm going to subtract x from both sides. That 27 minus 1 gives me 26x. Then I'm going to get rid of the 243, so I'll add 243 to both sides. So 26x, when I add this I get 260, and then I'm just going to divide by 26, and I get x equals 10. And in a logarithmic equation, I just need to make sure that this doesn't cause me to take the log of 0 or the log of a negative number. Those aren't allowed. So if I plug the 10 in up here, 10 plus 17 is 27. Log of 27 is fine. If I plug 10 in here, 10 minus 9 is 1. Log of 1 is fine. So I don't have to discount that as a solution, and that would be the solution to my equation.